You type a web address, hit the enter key, and the page appears before you can even blink. This speed makes it easy to view the cloud as a marketing abstraction, an invisible, magical fog where our data lives. In reality, the cloud is a physical network of copper and glass, and thousands of air-conditioned warehouses filled with humming server racks located thousands of miles away. To understand how the modern internet functions, we have to look past the metaphor and trace the physical journey a piece of pizza takes in the milliseconds after you press that key. A language barrier exists between humans and computer networks. We use recognizable domain names like newrelic.com, but networks require numeric IP addresses to route information. Bridging this gap is the Domain Name System, or DNS, the internet's translation mechanism. The process begins at your local device cache. If the IP address isn't found there, the request escalates to your ISP's recursive resolver.
If the resolver lacks the answer, it queries a root name server, which directs it to a top-level domain server, like the ones managing .com or .org, to narrow the search. Finally, the request reaches the authoritative name server for that specific domain. This server holds the actual IP address, which is then delivered back to your device. This multi-server interrogation happens in under 100 milliseconds, serving as the invisible directory that makes internet navigation possible. Now armed with a numeric destination, your device must navigate the physical internet infrastructure to deliver its request. Through network address translation, your device leaves its isolated private network and receives a public IP address that is routable on the global internet. This is the structure of an IPv4 address. Routers use subnet masks to identify which bits of this address refer to the broad network and which refer to the specific host machine. Modern networks use CIDR notation to remain flexible. By adding a prefix like /24, providers can allocate right-sized network blocks instead of relying on wasteful, rigid classes. To keep global routing tables efficient, routers use route summarization. They aggregate multiple contiguous subnets into a single supernet block, reducing the total number of entries the network must track. These systems function as a global zip code system, ensuring a packet of data can pinpoint a specific server rack halfway across the world without overwhelming the transit network. When the data packet arrives at the destination data center, it enters a shared resource pool rather than a dedicated physical server. This is the literal definition of the cloud, a shared pool of configurable computing resources that can be rapidly provisioned. Resource pooling is made possible by the Type 1 hypervisor. This software layer sits directly on the bare metal hardware of the server. The hypervisor partitions a single physical machine into multiple isolated virtual machines. Each VM runs its own operating system, unaware that it is sharing hardware with its neighbors. By partitioning rigid hardware into fluid, scalable resource blocks, the hypervisor allows multiple organizations to share physical infrastructure securely. Once the data reaches its virtual machine, the environment it interacts with is determined by the specific service model the client has purchased. In IaaS, the provider manages the hardware and hypervisor. The user controls the OS and apps. PaaS shifts this burden. The provider maintains the OS and middleware. With SaaS, the provider manages the entire stack, delivering a fully realized application. While the management responsibilities change depending on the model, the cloud always relies on the exact same physical infrastructure. The server processes the request, firing the data back through the network architecture to your device. This incredibly complex planetary scale process finally culminates in the simple, instantaneous loading of a web page on your screen. The internet is a physical machine using DNS translation, CIDR routing, and hypervisor virtualization, all executing a global commute in the span of a single millisecond.